Hi guys, let's move on to the next exercise. Next exercise is exercise 9b. Nothing new for me to teach, but let's quickly revise the test of congruency. The first test was SSS, all three sides are equal. Next was SAS. The third that we do was angle side angle. A variation of this is also known as angle side, and eventually the final one was RHS, the right angle, hypotenuse and side. So these are the 5 tests. This exercise basically involves the application of these 5 in different kinds of questions. And the key new skill to be learned in this exercise is to draw the diagram. In fact, most of these questions in this exercise will not have a diagram given, so you will have to draw a rough diagram and then try and do the question. So let's look at question number 1. On sides AB and AC of triangle ABC. So there's a triangle ABC. Let me start with drawing a rough diagram. So this is triangle ABC. All right. So let me name this A, B, and C. So on sides A, B, and C of triangles ABC, equilateral triangles ABD and AC are drawn. So on side AB, equilateral triangle ABD is drawn. So let me draw a equilateral triangle here, and this is equilateral, right? So this is the name of this triangle is ABD. Equilateral, which means this side, and this side are equal, and this is 60 degree, this is 60 degree, and this is also 60 degree. Like I said, my habit is to first draw and write whatever we know. So AC is on the side AC, triangle ACE is drawn. So let me draw a rough diagram for equilateral triangle ACE. So this is AC and this is E. So this is also 60 degree, this is 60 degree, this is 60 degree, and these three sides are equal. Perfect. So this is the information given to us. Let's see what do they want. Prove that triangle CAD. So CAD, also I will need to join C and D. Perfect. So prove the triangle CAD and angle CAD, or not triangle, CAD and angle BAE. So I will have to join BAE as well, BE as well. Okay, so CD and BE. So we're looking at angle BAE. Perfect. So this big angle. Prove that this angle is equal and CD is equal to BE. So CD is equal to BE. Perfect. The way I have written this, I think I already know my answer. Angle DAC or CAD is 60 plus A. Similarly, angle BAE is also 60 plus A. So we've already done that. Let's start writing the answer. Number 1, angle BAD is equal to 60 degree. Number 2, angle CAE is equal to 60 degree. Reason? Vertex angle of equilateral triangle. Perfect. So we've written the reason why they are equal. Number 3, angle DAC is equal to 60 degree plus angle BAC. Always a good habit to write angle in 3 letters. So this is it. Number 4, angle BAE, which is what the other angle. So we've done CAD, which is here, and angle BAE, which is what I'm doing here, is also equal to 60 degree plus angle BAC. From 3 and 4, we notice that angle DAC is equal to angle BAE. This is what they wanted us to prove. So part 1 is done, right? So hence proved. Done. Let's look at part 2 of this question. Part 2 of this question says prove that CD is equal to BE. So let's look at where is CD. CD is here and BD is here. So let's look at which triangle is CD a part of, which will help me prove them congruent. So this is CD and BE. Let's look at which triangle will they form a part of and some information given to us. So let's look at ADC. Let's look at this triangle ADC, and let's look at the triangle ABE. let's look at these two triangles and see if these two we can try and prove congruent. I could have also looked at another triangle. Let's say I could have seen triangle DBC and I could have seen triangle BEC. These are a part of these two triangles as well. Let me try and prove them, though in this case with DEB, yeah, and BAE. Let's look at this. Let me draw a rough diagram and see how it works. So DBC, not DB, DAC, sorry, DAC, not B, A. This is D, this is A, and this is C. And the next one is BAE. So this is BA and this is E. This is A, this is E, this is D. Let's see what all we know. I know that AD is equal to AB. Why are they equal? AD and AB are equal because they are a part of the same equilateral triangle. What else? I think AC is also equal to AE. Why is AC equal to AE? Because they also are a part of this equilateral triangle. AC and AE are equal. Anything else? Yes, angle A, which is angle DSC, is equal to angle BAE. We've already proven in part 5. So by side, angle, side. Now let's start writing the the method. Number 6, AD is equal to AB. Reason, we'll just write. Number 7, AC is equal to AE. Reason for this, both of them is sides of the same equilateral triangle. Done. And number 8, angle DAC is equal to angle BAE. Why? From point number 5. Therefore, by SAS test, number 9 would be triangle DAC is congruent to triangle DA is BA. So DA is BA, which means the third is E. So DAC is congruent to triangle BAE, which means CD will be equal to BE. CD 1 and 3 is equal to 1 and 3. Why? CP, CT, C. This is what they wanted me to prove. Part 2 is also done. So hence, I hope you realize drawing a rough diagram helps immensely, and writing down all the information that you have works. Let's look at the next question. The next question that we do is question number 2. Question number 2. In the following diagram, ABCD is a square. Okay, so ABCD is a square, which means these four sides are equal. So I am again pointing out and writing whatever information I have on the diagram itself. And ABB is an equilateral triangle. So ABB is an equilateral triangle, which means these three sides are also equal. And since these three sides are also equal, this angle is 60 degree, this angle is 60 degree, and this angle is 60 degree. Since this total angle is 90 because it's a square, which means this angle now is 30 degree, this angle now is 30 degree. Perfect. So this is basic information that I've already figured out. Let me see what I need to do. Prove that triangle APD, which is APD, which is here, and BPC, yes, which is here. I need to prove that these two triangles are congruent. Let me draw a rough diagram and see if I can do something. Let's look at this. So this is my P, D, and A. And let's say this is C, B, and P. So this is C, P, and P. So I know angle B is 30 degree. I've just calculated. I will have to write all that down, but let's start writing. Let's start noting down what all information I know. I know that AD and BC are equal because they are square. Let's see if there's anything else that I can prove. Any other angle which I can prove. Yes, I noticed that AP and BP are also equal. Why? They are equal because this is they are part of the same equilateral triangle. Perfect. So now I have side, angle, and side. My work already done. So let's start writing this down. Number one. Before I write number one, let's see. Let's refer to which triangles we are referring to. So in triangle APD and triangle BPC. So this is the two triangles that we refer to. Number one, AD is equal to BC. Why? Sides of same square. Perfect. Number two, the other one was AP is equal to BP. Sides of the same equilateral triangle. Perfect. Now we need to prove the third part, which is 30 degree, which we've done some calculation. So let's write angle BAD is equal to angle ABC is equal to 90 degree, vertex angle of a square. Done. Number 4, angle PAB is equal to angle PBA is equal to 60 degree. Why? Angles of a equilateral triangle. Done. Number 5, angle DAP is equal to 90 degree minus 60 degree is equal to 30 degree. Number 6, angle CBP is equal to 90 degree minus 60 degree is equal to 30 degree. Number 7, therefore angle DAP is equal to angle CBP is equal to 30 degree. So from 1, 2 and 7. So this was one side, this was one side, and this is the included angle. From 1, 2 and 7, triangle ADP is congruent to triangle BCP using SAS test. Done. This is my number 8. So they wanted me to prove it. I have done it. So this is done. Good habit to highlight your answer because there would be many steps or many parts of the question. So you should highlight each part as and when you do it. Let's look at angles of triangle DPC. So we are looking at triangle DPC. So I need to find out this angle, and this angle. And they are not equal. I'm just marking that these are the three angles that I need to mark. So basically I will need to find, I know this angle. If for finding this, I will have to find this angle and this angle. Let's see. So now I notice in triangle ADP, these two sides are equal. So what does it make triangle DAP? Yes, it makes it an isosceles triangle. So let this be X and this will also be X because this is an isosceles triangle and base angle will be equal. Similarly, triangle CBP is also isosceles. So let this be angle Y. So will I be able to measure this angle? This is X I am referring to, and this is also X that I am referring to. This is Y and this is Y. Perfect. So let's try and find these two angles, and then this will be 90 minus X. Why? Because this total angle is 90 and this will be 90 minus Y. Perfect. So we should be able to solve something. In triangle ADP, AD is equal to AP, right? Therefore, triangle ADP is isosceles. Therefore, angle ADP is equal to angle APD. My mistake, APD is equal to X. So 2x plus 30 degree is equal to 180 degree, which means 2x is equal to 150 degree, which means x is equal to 75 degree. So this angle is 75 degree. Similarly, in triangle BCP, BC is equal to BP. Therefore, triangle BCP is isosceles. So, therefore, angle BPC is equal to angle BCP is equal to y, which means 2y plus 30 degree is equal to 180 degree, which means y also is 75 degree. Perfect. So this angle is also 75 degree. This angle is 75 degree. This angle is 75 degree. Perfect. So now to calculate this angle, right? So this was number 8. Let's call this number 9. Let's call this number 10. Number 11. Angle ADC is equal to 75 degree plus angle PDC, which means angle PDC is equal to ADC is equal to I will need to write this is equal to 90 degree. Therefore, angle PDC is equal to 90 minus 75, which is 15 degree. So this angle is 15 degree. Similarly, number 12, angle PCD is equal to 90 degree minus angle PCB, which means 90 degree minus 75 degree, which means 15 degree. So this angle is also 15. So I will just make a rough diagram here. This is D, this is C, this is P, this is 15, this is 15, this is 15 degree, and this is 15 degree. Now what remains is for me to calculate the value of the third angle. And how can I do it? Yes, the sum of three angles of a triangle is 180 degree. Therefore, 15 degree plus 15 degree plus angle DPC is equal to 180 degree, which means angle DPC is equal to 150 degree. They wanted the three angles of this triangle. Well, I'm left with no space, so let me write this down here. Angle PDC is equal to angle PCD is equal to 15 degree, and angle DPC is equal to 150 degree. This is the angles of the triangle that they wanted. Very less space for me on this page, so that's why this part should have come right at the end. Perfect. Let's look at the next question. The next question that we do is question number 3. Let's look at question number 3. Question number 3 says in the given figure, ABC is a right angle triangle at B. So this is a right angle triangle at B. This is a 90 degree. ABPQ and ACRS are squares, which means this side, this side, this side, and this side are equal, and all these four sides are equal because these are squares. Similarly, all vertex angles are 90 degree. Right here also all vertex angles are 90 degree. Perfect. I have marked whatever I knew. We need to prove that ACQ and ASB are congruent. Let's draw these two rough diagrams. This is my angle AQC, that's my first triangle, and this is my second triangle, which is ASB. Let's see what all I know. So AQ is a single line, AB is a single line, so these are equal. Similarly, AS is a double line and AC is a double line. These are equal. So I have got two elements equal. Let me see if I can get a third element. So either I can get an included side or I can get CQ and BS equal. Well, I will not get that equal because this is the question. So I will not get that equal. So if I have two sides equal, maybe I should try this angle equal. Let's see. So this angle, which is QAC, is equal to 90 degree plus, let's say this is angle X. Similarly, angle BAS is equal to 90 degree plus X. Perfect. I think I've got my answer. This angle and this angle are equal. So this will be side angle side. So let's start writing. Number 1, let angle BAC is equal to X. Right? Therefore, angle QAC is equal to 90 degree plus X. Number 3, angle BAS is equal to 90 degree plus X. So this is 90 plus X, this is 90 plus X. Perfect. Number 4, AQ is equal to AB. Number 5, AC is equal to AS. The reason being sides of the same square are equal. Sides of the same square are equal. And number 6, angle QAC is equal to angle BAS is equal to 90 degree plus X from 2 and 3. Like I said, numbering it makes our life easier because you need to refer to that point somewhere later in the question. So makes reference easy. Next, therefore, by SAS test, triangle QAC is congruent to triangle Q is the smaller angle, triangle SAB. This is my point number 7. This is what they wanted me to prove, hence proved. Next part of the question, CQ and BS. So CQ 1 and 3 and BS. Number 8. Therefore, CQ is equal to BS. Reason CP. Hence proved. Like I said, good habit to highlight the final step where you prove whatever has been asked in the question. Let's move on. Let's move on to the next question. The next question that we do is question number 4. So question number 4 says, in triangle ABC, BD is median to the side AC. Okay, so let's start drawing a rough diagram. It says, in triangle ABC, BD is the median to the side AC. BD is produced to E such that, what does produce mean? That you're increasing the length and taking it forward. So let's look at this. So BD is median, which means it bisects side AC into 2 equal parts, and this is produced, it's taken further to E such that BD is equal to DE. So this is D and this is E. It is produced such that BD and CE are equal. So this is what the question is. Since it's a median, which means AD and BC are equal. So let's look at this again. ABC was a triangle. We had a median BT which was produced further to point E in a manner that BD and DE are equal. And since this is a median, AD and BC are equal. Perfect. Prove that A is parallel to BC. So let's join A and E. So I need to prove that AE is parallel to BC. Perfect. So how can I prove something parallel? Yes, if you remember your properties of parallel lines and transversal, I can prove them parallel by if corresponding angles are equal or alternate angles are equal. So let's see if I can prove any of these two angles equal. So if alternate angles, which means angle A here and angle C, or angle E and angle B. Let's see what I can prove congruent. So let's look at the question if I can figure out something. Let's look at these two triangles ADE and BDC. So in triangle ADE and triangle BDC, I notice I've already got two sides equal. Right? These two sides are equal. Can I get some third side equal? Not given. Can I get any other angle equal? Yes, I notice that this angle and this angle will be equal because these are vertically opposite angles. Perfect. My answer is done. Side, angle, side. Now to write it down. This is A, this is E, this is D, and this is D, this is B, this is C. This angle and this angle are equal. AD is equal to BC and BD is equal to DE. All this is information that we figured on our own. Let's start writing. Number 1, BD is equal to DE, given. Number 2, angle BDC is equal to angle EDA, vertically opposite angles are equal. So vertically opposite angles are equal. I've got this point now. Let's look at the third one. AD is equal to BC. Why? Since BD is median, which means median divides the opposite sides into two equal parts. Therefore, by SAS test, number 4, triangle ADE is congruent to triangle CDE, ADE, CDB. So these two triangles are congruent, which means angle E and angle B are equal, which means angle A and angle C are equal. So number 5, therefore angle DAE is equal to angle DCB. Since these are alternate angles and they are equal, therefore AE is parallel to BC. Perfect. Anything else they want me to prove? No. So AE is parallel to BC, hence done. Let's look at the next question. The next question that we do is question number 5. Let's look at this question. Question 5 says, in the adjoining figure, QX and RX are bisectors angle Q and R. So these are bisectors, which means let me start writing what I know. So this angle and this angle is equal because these are bisectors. And this angle and this angle are equal because this is bisecting this angle. Perfect. Q and R are respective, okay, of the triangle. QS is perpendicular to QR. QS is, XS is perpendicular to QR and XT is perpendicular to PQ. Perfect. Prove that XTQ and XSQ. So XTQ and XSQ. Let's see. These are the two triangles that we're looking at. XTQ and XSQ. Okay, so I have two angles equal, 90 and this, and I have a common side. So right angle, hypotenuse. No, this is not side, this is angle. So angle, angle, side. That's what I have done. Chalo, I have already figured my first answer. Let me draw a rough diagram and move on. So this is my first one. This is X, this is T, this is Q, and this is the second one. This is S, this is X, and this is Q. So in triangle QTX and triangle QXS, number 1, angle TQX is equal to angle SQX. Why? Since QX bisects angle PQR. Done. So this is part 1. Part 2, the second angle that is equal is angle QTX is equal to angle QTX is equal to angle QSX is equal to 90 degree. This is given. So this is the second angle, and the third side, which is QX, is equal to QX, not S, QX. So this angle and this angle were equal, and QX and QX are equal because this is common arm. This is common side, whatever you call it, side or arm. Therefore, by AAS test, triangle QTX is congruent to triangle QSX. This is the first part that they wanted me to prove. This is my number 4. Hence proved. Now I need to get to the next part. The next part is PX bisects angle P. Oh, so I have to draw a diagram here. PX bisects angle P. So I need to prove that this angle and this angle are equal. Now, can I see any triangles where this will part of? Yes, this will be PXQ and PXR. Do I know anything else about them? No, I know nothing. Maybe I should try and do something else to prove this congruent. So let's see. So this would mean that xt is equal to xs. This is CPCTC. I've got this side equal to this side. Done. Let me draw a perpendicular from x onto PR. Let's call this Z. So let's number 6. Draw XZ perpendicular to PR. How does this help? Let's look at this. Maybe it does. Let's look at this. So now let's look at these two triangles, which is XZR, which is this triangle XZR, and the second triangle being XSR. XZR and XSR, these two triangles. Let's see if I can prove them congruent and if this helps me. I think it will, because I will be able to get this side and this side equal. Let's try. So in triangle XZR and triangle XSR, let's draw these two triangles separately. So I have XZR, this is Z, this is X, this is R, and the next one is XSR. So this is S, this is R, this is X. Let's see if we know anything. Number 7. Angle XZR is equal to angle XSR is equal to 90 degree. This is given. So we've taken this to be equal. Anything else that we know? We know angle R and angle R are equal. This angle and this angle. Why are they equal? Because this is also given. So angle R and angle R are equal. Let's write this down. Angle XRZ is equal to angle XRS, because XR bisects angle PRQ. Done. So I've got two sides equal, anything, two angles equal, yes, and anything else equal, yes. XR and XR are equal. So XR equal to XR. Why? This is common side. Anything else I can get? So this is again angle side. Therefore, by angle side test, number 10, triangle XZR is congruent to triangle XSR. Correct? XZR and XSR are congruent, and that gives me to another point which I wanted to prove, which is XS is equal to XZ. So XS is equal to XZ. This will help me in the next step. So this is CPCTC. Now let me try and prove these two triangles congruent. So let's write this down. So in triangle PTX and triangle PTZ, again rough diagram to help. This is P, this is T, and this is X, and this is Z, this is P, and this is X. So I just got, this is one angle is equal, PX and PX are equal, which means right angle hypotenuse. I need to get one side equal. I think I've already got that side equal, which is, let's see, TS and XT are equal, which means TS and XT are equal, but XS and XZ are also equal, which means TX and XZ are equal. Let's write this down. Number 12. XS is equal to XT is equal to XZ from 5 and 11. So I have got XS is equal to XT, which is equal to XZ. So I've got now right angle, hypotenuse and side, which makes my life simple. So next one is angle PTX is equal to angle PZX is equal to 90 degree. So I've got a right angle, I've got a side. Let's look at hypotenuse. Hypotenuse PX is equal to hypotenuse PX. Why? Common side. Therefore, by RHS test, triangle PTX is congruent to triangle PZX. Perfect. That's my number 15. Therefore, the number 16 would be angle TPX is equal to angle ZPX CPCTC. Therefore, PX bisects angle QPR. Done. Notice that this question was very interesting. It had many steps. So first, this one was simple, which is XTQ and XSQ was simple. We proved them congruent. And once we proved them congruent, we constructed another perpendicular from here to here. We proved these two triangles congruent. We did all this to get this side and this side equal. Now, once we got this side equal, this was 90, this was 90, and hypotenuse common, which means this angle and this angle, which are corresponding, will be equal, and that's why PX bisects this angle. That's about it. Homework question. Homework would be for you question number 2. There's a second diagram, so part 2 of part 2, which means that same question, but the diagram for it is different. Thank you so much. Take care. Be safe.